Hello everyone, in this video we are going to talk about the graphs of sine and cosine function, and in this specific video we're going to cover the introduction of the graph and sine and cosine function. So let's do a quick review. When we talked about sine and cosine, we will consider these unit circle on a coordinate plane. And we have a circle in here. Let's say this angle is theta. And the value that the angle intercept with the unit circle, this point with the coordinate x and y. Then we have sine theta is equal to our coordinate y, and the cosine theta is equal to the coordinate x. So now the first thing is, let's do some quick review. When theta equals to 0 degree, which means when the graph is in here, I'm going to use a yellow pen, right? So what's the value of, let's start with cosine, since cosine is x or sine, either way, whichever makes easier, maybe sine theta. So when this is at 0 degree, which is the yellow line, what happened to the y coordinate? So y at this point in here equals to what? 0? No, 1, 0. Oops. It's 1, 0, right? So our value sine 0 is equal to the y value, which is 0. Now, what about pi over 6, which is 13 degree? When it comes to 13 degree, the graph is approximately in here when this is 13 degree. And now we don't need to consider the x value for now. Now we just need to consider the y value because we just discussed about the sine's function. Well, if we use the triangle, we will find out that, hey, this is 1, 2 square root of 3. So sine 13 degree, which is sine pi over 6, is equal to 1/2. And we continue. Let's list what's about 45 degree. If sine 45 degree, which is pi over 4, is equals to square root of 2 over 2. When it comes to 60 degree is equals to square root of 3 over 2. And then when theta is 19 degree, which is pi over 2, which is when it's at in here, the blue dots, what happened? What's the coordinate? Which is when x equals to 0, y equals to 1. So that means when theta is equal to 19 degree, sine 19 degree, which is pi over 2, is equal to 1. Well, you can repeat and continue these. Let's say at another 13 degree, which is 2/3 pi. No. Yeah, 2/3 pi. This is equal to square root of 3 over 2. And then next one is 135 degree, which is 3/4 pi, which is square root of 2 pi. And then the next one would be 115 degree, which is 5 pi over 6. Oops. So that gives you 1/2. And then next one is when it comes to pi, which is 118 degree, which is in here. I have x equals to -1, y equals to 0. So that the value is equal to 0. Now, Consider this is our x-axis and this is y-axis. And now let's draw the graph and see what does the graph look like. So I have a y1, -1. Oops. Pi over 6, pi over 4, pi third, pi 2, and then continue. Now, when x equals to 0, y equals to 0. Use a different color. When x equals to maybe pi over 6 is equal to 1/2. And then when x equals to, let's enable different points. Pi over 2, we got this is equal to 1. And then when it comes to 2/3 pi, we got square root of 3 over 2, maybe it's here. When x equals to pi, we have sine pi equals to 0. So connect all of these points together, we may get a graph look like this way. In fact, as you continue to list the value from 0 to 2 pi, which is the whole unit circle, our unit circle is from 0, here is pi half, when it comes to 100 degrees is pi, and then 3 pi over half over 2, and then go back to 2 pi. The whole unit circle is 2 pi. So if it comes back, you will notice that the graph look like this way. So in here, you will get 2 pi. Here you will get a -1 when it comes to 3 pi half. So this is a graph of a sine function. Now let's start the graph similar. We use the similar idea to draw a graph of a cosine function and see what does it look like. So we got theta, cosine theta. Again, we start this with a 0, and then pi over 6, pi over 4, pi over 3, which is 16 degrees, half pi, and then 2/3 pi, 3/4 pi, and then add another 5, 6 pi, and then pi. And then remember, the cosine is the same value of the x-coordinate. When it started, when theta is equal to 0, which is the yellow label dot in here, which is pointed at here, which is theta equals to 0, we have the coordinate 0 and 1 to 0. So that means cosine 0 degree is equal to 1. And then pi 6 is equal to square root of 3 over 2 and square root 2 over 2, 1/2, 0. And now let's take about 2/3 pi, which is in here. I'm going to use a green one. This whole angle is 2/3 pi, which is equal to 2 pi half plus pi 6. Pi half plus pi 6, which is 19 degrees at 13 degrees. So what would be the reference angle? So in this case, the reference angle is equal to 60 degrees, right? Which is pi third. So what happened to the reference angle? So reference angle will give you the same value, and then what we need to consider about is the positive or negative sign. Since we're talking about the cosine function, so the cosine function, and this is in the second quadrant, right? So in the second quadrant, cosine function is going to equal to negative. So that this is going to equal to the negative of the reference angle. And our cosine pi third, which is cosine 60 degree, is equals to 1/2. So that's why cosine 2/3 pi is equal to negative the reference angle of the 2/3 pi, so that which is equal to negative 1/2. And you can do the same thing for the rest of the angle. So I will have, this is -1, because when it comes to 118 degree, which means it's in, let me use a purple. 180 degrees here. So when theta is 180 degree, which is cosine pi, I have this point is -1, 0, and the cosine is the x value, which is -1. So here we got -1. Now let's draw this graph and we'll take a look. What does this graph look like? So again, 1, -1, 1/2 pi, oops. The next one is pi, and then when at 1/2 pi is equal to 0, when it comes to pi is equal to 1. So the graph starts in here, goes down. Later you will notice that if we keep continue, the graph will goes back up, look like this. So here's the cosine function. But right now we are just drawing from 0 to pi. Okay, so here's how we draw the graph of sine and cosine function. Now let me show you in decimal what does the whole function look like. Okay, here is our decimals calculator. And in here on the upper right, we have a graph setting, and then we can set the graph, the x-axis, the range of x-axis, the domain, I should say, the domain of the x-axis, and then the range of the y-axis. So let's put in sine x. Look at this graph. If I can choose it, I may choose the y-axis from -2 to 2, or you can choose it from 2 to 1. I just want the graph looks bigger or smaller. 5 and then 5. And now let's take a look at x-axis. X-axis is from -10 to 10, which is fine. And in here, the step, we can change it for every pi. So you can see every time when you see a pi, they will label it for every pi, -2 pi and -3 pi. Or we can make it pi over half, which is we're more familiar with. So that means every 60 degree, they will have the label. Okay, now let's take a look what happened to the graph. As you can see, this is a sine x from 0 to 2 pi. It looks like this way, the wave. It starts with a 0, 0 and ends at 2 pi 0. Now, take a look at cosine x. Let me cross it. Cosine x is more like from 0, 1 on the top, goes down and up back to 1. The y value equals to 1 from 0 to 2 pi. So as you can see, the graph is repeat, right? Repeat in every 2 pi. So we call this is called periodic function. That means in every 2 pi, the function will repeat. So you can see from 0 to 2 pi, maybe I can make the range even bigger. Let's say x is from -1 to 50. Maybe that's too big, 50, or 8 pi. Let's take a look. What happened to the graph? From 0 to 2 pi, the graph looked like exactly the same as from 2 pi to 4 pi. And from 4 pi to 6 pi, they look the same in cosine function, similar to sine function. From every 2 pi, from 0 to 2 pi, and then from 2 pi to 4 pi, these two sets, they look the same. So we call this as periodic function. And also another thing is take a look at sine and cosine. They look like a little bit off. How can we align them? Is there any way to align them? So maybe we can shift the cosine function a little bit to the right and see what happens. Well, we already learned how to shift in Math 141. If we want to shift to the left, we want to minus some value, maybe -2. Well, that still looks a little bit off. So how much do you think we should minus? So in this case, maybe it's not just a number 2. We want to minus a radian. So maybe instead of 2, we want to minus 2 pi. Well, nothing changed because 2 pi is periodic function. So that means the function repeats every 2 pi. So maybe we try pi. They're still off. Maybe it's pi half. Look, now they're aligned. So that means when sine and the cosine x minus 2 pi, when you shift to the left, pi over 2 units, these two functions will overlap it. Okay, so let's discuss more about that. First of all, the range of the function. As you observe on my open math, the range of sine and cosine function is from -1 to 1. Range is all the possible value for the y value, which means the horizontal axis, the maximum and the minimum is from -1 to 1. And then second is in both graphs, you can see the shape repeats after every 2 pi, which means the function is periodic with a period of 2 pi. So we call this as a periodic function. That means a function for which a specific horizontal shift p results in function equals to the original function. Which is fx plus p equals to fx. So in our case, specifically, such as sine x function, if we add 2 pi, they will look the same. Now, let me show you on my open math. Here, I'm going to cover, we don't look at sine cosine function anymore. Now we add a function sine x plus 2 pi. It's in black line. Look, they all look the same as the blue graph, right? Now, if I want to add another sine x plus 10 pi, see what happened? These three all align, right? The black one, the blue one, the black one and the green ones, and the red one, they all align. So that means, what do they tell you? So that means sine x is equal to sine x plus 2 pi or sine x plus 10 pi for every 2 pi, or even subtract, because the repeating period is every 2 pi, so it can be add or subtract 2 pi's multiple. Okay, similar to cosine. So cosine x is equal to cosine x minus 20 pi, or equals to cosine x plus 14 pi, because they repeat. All right. Also, by observation, we also notice that sine x is equal to cosine x minus 2 pi. So that means when cosine x shift to the right, pi over 2, these two graphs is going to be overlapping. That tells you what? Well, remember that the sine and cosine are co-function. So that makes sense, right? Because the definition of co-function is the cosine of an acute angle is equal to the sine of is complement. So that sine and cosine are co-function, which results in the graph will be overlapping after you make a horizontal shift to the left to the right, pi over 2. Okay, so here's one exercise. So on a 0 to 2 pi scale, which means this is the limit, the x-axis, only from 0 to 2 pi. And I want you to solve fx equals to 1/2 for fx equals to sine x. What does this graph mean? What does this question mean? This question means that when sine x equals to 1/2, what is the value for x? So when sine x equals to 1/2, what value of x? Okay, now let's take a look at our graph. Let me clean up everything else. So we have sine x. Since we only care about the graph from 0 to 2 pi, we can just start in here, 2 pi. Now, let's take a look at this graph. Or maybe we can have a little bit of, maybe with -1. So we can be more clear. So when you look at this graph, and then we want to know when y equals to 1/2, this is equal to what? So now let's look at the intercepting point. We have it in here. Oh, 1/2, not 1/3. We have it in here, this point. If you point this point, it will label it. So now we have pi 6. When x equals to, or theta equals to pi 6, then y is equal to 1/2 or 5 pi over 6. Now, let me write down this. So that means when we observe from the graphing calculator, when x equals to pi 6 and x equals to 5 pi 6, we have our y value, which is our sine x equals to 1/2. So that would be the solution. So have you think about y is 5 pi over 6, also equals to 1/2? Well, if you look at a unit circle, here, 5 pi over 6 is in here, right? This is theta equals to 5 pi over 6. And what is reference angle? Well, its reference angle is this guy, which is theta equals to pi over 6. And we know that the value of a reference angle are the same as that angle. So that means we have sine pi over 6 should equal to sine 5 pi over 6. And we know that since this is in second quadrant, so our sine is going to, both sine are going to equal to positive, so that these two are equal. So our solution is pi over 6 and 5 pi over 6. Okay, next part, let's talk about the symmetric of the function. Oops. So the symmetric function, for sine's function, we know that sine's function look like this one. And continue and repeat the pattern. And the sine's function, we talked about that earlier when it comes to the even and odd function. For every sine's function, it's going to be symmetric over the origin, which is 0, 0, which makes it to become an odd function. And then cosine function. Cosine function look like this. So this is going to be symmetric over the y-axis. That makes it to become an even function. So what's special about the odd function and even function? For every odd function, we got in general, we have fx equals to negative f of negative x, which is negative fx equals to f of negative x. In this specific case, we will have negative sine x equals to sine of negative x. Whereas odd function is more like fx equals to f of negative x. So that means when it comes to cosine function, we will have cosine x equals to cosine negative x. Okay, that's it for this chapter or this section. I'll see you in the next video.